Solar Storm Warning, presented by Science at NASA. March 10, 2006. It's official. Solar minimum has arrived. Sunspots have all but vanished. Solar flares are non-existent. The sun is utterly quiet. Like the quiet before a storm. This week, researchers announced that a storm is coming, the most intense solar maximum in 50 years. The prediction comes from a team led by Masumi Dickpati of the National Center for Atmospheric Research. The next sunspot cycle will be 30% to 50% stronger than the previous one, she says. If correct, the years ahead could produce a burst of solar activity second only to the historic solar max of 1958. Now that was a solar maximum. The space age was just beginning. Sputnik was launched in October 1957, and Explorer 1, the first U.S. satellite, in January 1958. In 1958, you couldn't tell that a solar storm was underway by looking at the bars on your cell phone. Cell phones didn't exist. Even so, people knew something big was happening when northern lights were sighted 3 times, in Mexico. A similar maximum now would be noticed by its effect on cell phones, GPS, weather satellites, and many other modern technologies. Dickpati's prediction is unprecedented. In nearly 2 centuries since the 11-year sunspot cycle was discovered, scientists have struggled to predict the size of future maxima, and failed. Solar maxima can be intense, as in 1958, or barely detectable, as in 1805, obeying no obvious pattern. The key to the mystery, Dickpati realized years ago, is a conveyor belt on the sun. We have something similar here on Earth, the Great Ocean Conveyor Belt, popularized in the science fiction movie The Day After Tomorrow. It is a network of currents that carry water and heat from ocean to ocean. See the diagram below. In the movie, the conveyor belt stopped and threw the world's weather into chaos. The sun's conveyor belt is a current not of water, but of electrically conducting gas. It flows in a loop from the sun's equator to the poles and back again. Just as the Great Ocean Conveyor Belt controls weather on Earth, this solar conveyor belt controls weather on the sun. Specifically, it controls the sunspot cycle. Solar physicist David Hathaway of the National Space Science and Technology Center explains. First, remember what sunspots are. Tangled knots of magnetism generated by the sun's inner dynamo. A typical sunspot exists for just a few weeks. Then it decays, leaving behind a corpse of weak magnetic fields. Enter the conveyor belt. The top of the conveyor belt skims the surface of the sun, sweeping up the magnetic fields of old dead sunspots, he continues. The corpses are dragged down at the poles to a depth of 200,000 kilometers, where the sun's magnetic dynamo can amplify them. Once the corpses, magnetic knots, are reincarnated, amplified, they become buoyant and float back to the surface. Presto, new sunspots. All this happens with massive slowness. It takes about 40 years for the belt to complete one loop, says Hathaway. The speed varies, anywhere from a 50-year pace, in other words slow, to a 30-year pace, or fast. When the belt is turning fast, it means that lots of magnetic fields are being swept up and that some future sunspot cycle is going to be intense. Here we have a basis for forecasting. The belt was turning fast in 1986 through 1996, says Hathaway. Old magnetic fields swept up then should reappear as big sunspots in 2010 through 2011. Like most experts in the field, Hathaway has confidence in the conveyor belt model and agrees with Dickpati that the next solar maximum should be a doozy. But he disagrees with one point. Dickpati's forecast puts solar max at the year 2012. Hathaway believes it will arrive sooner, in 2010 or 2011. History shows that big sunspot cycles ramp up faster than small ones, he says. I expect to see the first sunspots of the next cycle appear in late 2006 or 2007, and solar max to be fully underway by 2010 or 2011. Who's right? Time will tell. Either way, a storm is coming. This story was written and read by Tony Phillips. It's presented by Science at NASA. To find more Science at NASA stories on the Internet, please visit science.nasa.gov.